Hello everybody, my name is Thanh. I'm welcome all of you to my class. Today we learn about 40.4 divisions of algebraic expression continue polynomial divided by polynomial. Our lesson 4 part 1 warm up, part 2 divisibility, part 3 divisions with remainder. Part 4 practice, part 5 homework. Let's start now. To get into today's lessons, I will get into the warm-up. Let's start with our exercise. Match to the correct answer to the following divisions. We have 1 minute to do the exercise. Time lapse. Now I invite a student to answer the question. 24 times x times y squared times z cubed divided by 6 times y times z squared must with 4 times x times y times z. 63 times a squared times b to the power of 4 times c to the power of 6 divided by 7 times a squared times b squared times c squared must with 7 times b squared times c to the power of 4 and 9 times x squared times y squared times 3 times z minus 24 divided by 27 times x times y times z minus s must with x times y. So, calculate 7 times x squared plus 14 times x divided by x plus 2. To solve the problem, we need to how to do the divide polynomial by polynomial. Let's go to today's lesson to know how to solve this problem. Lesson 14.4 Divisions of algebraic expression continue polynomial dividends by polynomial. I'm going to part 1. Divisibility. So, how do I divide 7 times x squared plus 14 times x with x plus 2? We have two ways to do the expression, and I do the first solution. Solution 1. We see this example 1. We shall factorize 7 times x squared plus 14 times x first to check and must factor with the denominator. 7 times x squared plus 14 times x. Now, I see 7 times square is the GCF. 7 times x squared divided by 7 times x is simple x. 14 times x divided by 7 times x is true. Now, 7 times x squared plus 14 times x equal 7 times x plus 2. Now 7 times x squared plus 14 times x divided by x plus 2 equals 7 times x plus 2 divided by x plus 2, and we are canceling the factor x plus 2 equals 7 times x. Now I'm going to the solution 2. 2 divided polynomial 7 times x squared plus 14 times x by polynomial x plus 2. We do as follows. Contrast the divisions. Divide by highest degree terms of the dividends by the highest degree term of the divisor. 7 times x squared divided by x equals 7 times x. Multiply 7 times x by the divisor x plus 2. Then subtract the resulting product from the dividends. Now 7 times x plus 2 equals 7 times x squared plus 14 times x. 7 times x squared, the 2 wins cancel and is equal to 0. Next, 14 times x minus 14 times x is equal to 0. And the last remainder equals 0, and we get the quotient 7 times x. We have 7 times x squared plus 14 times x divided by x plus 2 equals 7 times x. The division that has 0 remainder is correct. Divisibly. I'm going to the part 2. Divisions with remainder. Calculate 5 times x cubed minus 3 times x squared plus 7 divided by x squared plus 1. Solution 1. 5 times x cubed minus 3 times x squared plus 7 equals 5 times x cubed plus 5 times x minus 3 times x squared minus 3 minus 5 times x plus 10 equals 5 times x squared plus 1 minus 3 times x squared plus 1 minus 5 times x plus 10 equals x squared plus 1 times 5 times x minus 3 minus 5 times x plus 10. I see quotient equal 5 times x minus 3 and remainder equal negative 5 times x plus 10. and the solution true by using long division methods. Now, contrast the divisions. Divide the highest degree terms of divided by the highest degree terms of the divisor. 5 times x cubed divided by 5 by x squared is equal 5 times x. Multiply 5 times x by the divisor x squared plus 1 equals 5 times x cubed plus 5 times x. Now, I see 5 times x cubed minus 5 times x cubed is equal 0. So, you could bring down to negative 3 times x squared and negative 5 times x plus 7. Then, negative 3 times x squared divided by x squared is equal negative 3. Now, I see negative 3 times x squared plus 1 is equal negative 3 times x squared minus 3. Subtracting the products of negative 3 and the divisor from the first remainder, we get the second remainder. Negative 3 times x squared minus negative 3 times x squared is equal 0. And you could bring down to negative 5 times x. 7 minus negative 3 is equal 10. We observe that the degrees of the remainder polynomial negative 5 times x plus 10 is 1 and lesser than the degrees of the divisor polynomial is equal 2. Hence, the divisions cannot be continuous. The divisions as in this case is called divisions with remainder. Negative 5 times x plus 10 is called remainder, and we have a 5 times x cubed minus 3 times x squared plus 7 is equal x squared plus 1 times 5 times x minus 3 minus 5 times x plus 10. Note, it is proven that for any two polynomials of the same variable a and b different 0 exists exactly one pair of polynomial q and I such that a is equal b times q plus I polynomial I is equal 0 or has degrees lesser than degree of polynomial b. I is correct the remainder of the divisions of a by b. Now, I'm going to the part 3. Practice. Let's start with our example 1. Divided 14 4 times x to the power of 4 minus 5 times x cubed minus 24 times x squared by 11 times x minus s. Now, I invite all students to answer the questions. Thank you. Solution: factorizing 14 4 times x to the power of 4 minus 5 times x cubed minus 24 times x squared. We get 44 times x to the power of 4 minus 5 times x cubed minus 24 times x squared equal 14 4 times x squared times x squared minus 5 times x minus 24 equal 44 times x squared times x squared minus 8 times x plus 3 times x minus 24 equal 14 4 times x squared times x minus 8 plus 3 times x minus 8 equal 14 times x squared times x plus 3 times x minus 8. Therefore, 14 4 times x to the power of 4 minus 5 times x cubed minus 24 times x squared divided by 11 times x minus 8. I see. We are cancelling the factor 11 times x minus 8 equal 2 times x plus 3 equal 4 times x plus 3. Now, let's work on another example 2. Dividend z times 5 times z squared minus 80 by 5 times z plus 4. Now, I invite one student go to the board. Thank you. Solution example 2. Dividends equal z times 5 times z squared minus 80 equals z times 5 times z squared minus 5 times 16 equal z times 5 times z squared minus 16 equal 5 times z plus 4 times z minus 4 using the identity a squared minus b squared equal a plus b times a minus b. Thus, z times 5 times z squared minus 80 divided by 5 times z plus 4 equal 5 times z minus 4 times z plus 4 divided by 5 times z plus 4. Now, I see. We're cancelling 5 times z plus 4 equal z minus 4. Now, I work in your pattern and do the exercise for group activity. Everyone look at the board, please. We have 5 minutes to do the exercise. Time's up. I invite 2 groups to the board. The solution to this board is 1. 5 times 2 times x plus 1 times 3 times x plus 5 divided by 2 times x plus 1 is equal 5 times 3 times x plus 5. 2. 26 times x times y times x plus 5 times y minus 4 divided by 13 times x times y minus 4 is equal 2 times y times x plus 5. 3. 52 times p times q times I times p plus q times q plus I times I plus p divided by 104 times p times q times q plus I times I plus p is equal 1/2 times I times p plus q. 4. 20 times y plus 4 times y squared plus 5 times y plus 3 divided by 5 times y plus 4 is equal 4 times y squared plus 5 times y times plus 3. 5. X times x plus 1 times x plus 2 times x plus 3 divided by x times x plus 1 is equal x plus 2 times x plus 3. Let's move on to the last part of today's lesson for homework. Homework 5 textbook and exercise 44.4. See you again and remember your homework. Thanks for listening.